In this content, we are going to run GPT2 and the Mistral model on Jetson Orin NX board. There are a couple of ways to do that. So for the GPT2 is quite old model, one of the old models from 2019, and we are going to use pytorch for it. But you can run with the TensorFlow either, or you can run, there are a couple of ways, there are a couple of tricks. You can run with different frameworks also. But my idea is here to show you what is the difference, with the different frameworks. So for the GPT2, it's quite old model, but you will see what you should do to run it. And we are going to build the pytorch itself because sometimes you have any problem when Jetson, the NVIDIA shares the pytorch on the internet, but sometimes when you install it pre-compiled pytorch, you can have some kind of problems. So you will see how you can build the pytorch on the Jetson board, even if it is small, not enough memory, let's say. For the Mistral, we are going to use a llama framework, which will make everything more easier in our case that you will see at the end. If you don't want to watch for the GPT2, you can just switch, like a jump in the video. And we are going to run the Mistral model easily with the llama framework. And also you will see that how we can run the Mistral model with a web server. So you can access from your phone, from your laptop at home or in your local area using simply the small Jetson Orin NX board. So let's start. So to install pytorch to run the GPT model on Jetson Orin boards, I have a Jetson Orin NX now. Now I'm recording the terminal from the Jetson Orin NX itself. So now we are going to install some kind of dependencies first, and I'm going to show you how to build yourself the pytorch. But I recommend first for you to follow the website that you can find the pytorch wheel file. So you can simply install the wheel file using the pip install, whatever the file name. But sometimes it does not work. So in my case, it didn't work in the runtime. I was able to install it successfully, but in the runtime, it gave me an error. And it was kind of the dependency error. One of the shared object file, the dependency was missing. And actually, I don't need this dependency. Then I decided to build myself. And I saw bunch of problems. First, it will take time because we try to build the pytorch on the Jetson itself, which has limited RAM, limited capacity, limited memory. So it will take some time. But you can do it at the end. It's just a couple of hours. First, you need to install the dependencies. You need to update your Jetson, and they file the OMP files and GCC it for the compilation. First, you need to check the CUDA version, because this is important. According to this version, you need to decide the tag you need to check out in the repository. So just if you use the Jetpack or the NVIDIA, the SDK manager, so you will have the CUDA. You don't need to do something else extra, simply version. And I have now 12.6. So the CUDA is important for the pytorch, right? Because we are going to enable the CUDA. And when we are going to run the model itself, the GPU will be used. So CUDA is used by, CUDA will use the GPU. So CUDA should be there. This needs your system need to support CUDA. And also you need to check CUDA DNN, and you need to check DNN libraries. If you have just running this command gives you the output, then it is okay. That means you have CUDNN libraries, it is enough. If it is not there, and you see the versions also, if it is not there, you need to install them. But as I told you, if you use the Jetpack, the SDK manager, to install the image in the beginning, then you don't need to do something more. If you choose everything, like all the CUDA versions, everything to the packages while installing, during the image, flashing the image, then it is okay. I have a pytorch before here, but you can simply, git clone pytorch. So it will clone it here. I'm not going to do it again. I did it already. I built it already. I just wanted to show the steps. So according to time, the steps can vary a little bit, can be different a little bit. But you need to try it first to understand which dependency you need and which dependency you don't need. Then just clone it, and it will take some time. It's because pytorch is a huge library. So compilation is also a problem a little bit. That's why I'm going to show you the steps. So when I check let me show you. When I check the website from the Jetson, I'm using now Jetson, the Jetpack 6.1. And if you search pytorch, like here for example 6.1. Let me make it a bit smaller. Yeah, here pytorch for jetpack 6.1. so this is the wheel file. You can directly install this from here, and instead of building it yourself, compiling it yourself, you can install this, but sometimes it does not work. So this is the case for me now, and I tried to build it myself. That's what I'm going to show you. Maybe you can need it later. So this means the 2.5 is the version file for the type pytorch. Means we are going to check out this version, git checkout 2.5. Otherwise you can have a problem, So because this version is compatible with the CUDA version that I have. That is why you have to be careful. Otherwise you will have other problems. But as I told you, just try to first install this, and if it does not work, then just try to build it yourself, compile it yourself. So I am already, I think, but you can just with git checkout command and v2.5.0. Then if you check out it, you will have a correct version. You need to also install, like a updated submodule update init, because there are other submodules that you need it later. Otherwise, you can have a problem. Recursive, you can add a recursive for now. You need to run this command. It will take again some time, and you need to export a couple of the variables, the flags, before build. One of them is, let me copy all of them here. One of them is use CUDA. So means during the build, build process, CUDA will be checked. So that means pytorch will use CUDA. So it should use CUDA because we have a CUDA now. We have NVIDIA GPU. And also for the QDNN that I showed you, the dependencies. Then, so I'm going to disable the sparse tensor support here. That was the dependency that I had a problem. So I'm going to disable it. And, the tensor, the pytorch that I am going to build will not have this feature. So means like a sparse tensor will not be used, but in my case, this is not needed. Then use sparse tensor 0. This is also the disabled sparse tensor again. But you need to try. I got this error during the runtime, so you need to be careful about it. So first you need to try it, then you will see the dependency, then you will check if it is necessary. Then you cannot disable it. You need to check more. If it is not needed for you, then you can simply disable it here. And the one that I disabled, actually the version for the orin NX that I have, you can check from internet again. CUDA arc the list. This is the version that I have. I'm going to share these comments. Don't worry, everything, the steps you can find it below the video. There will be probably a link or something, or you can find the comments itself. And 8.7 that I just found on the internet. And I need to give CMake prefix path. This is just a necessary step to, for the path to CMake that the Python is, here. Now, while I was building the pytorch, doing the compilation, I saw a couple of memory problems because I have the NX here, Jetson Orin NX has 8 GB RAM, and 8 GB RAM is not enough. Some dependencies, some objects, some libraries, while doing the binding, is interestingly, it needs capacity more than that I have here for the RAM, more than 8 GB RAM is needed. And that is why I was thinking to create a swap area. It makes the process a bit slower, but it makes things, working. So to create a swap area, I'm not going to write it again to run because we need also the swap area while running the big models. I'm going to show you later. So that's why I don't want to create one now, but simply you need to run sudo fallocate fallocate -l 16 GB. I gave 16 GB. I tried 8 GB, didn't work. Swap file. Then you need to give. I can do it one by one. I think you need to change the permission. Swap file. So swap file means there is if you don't have enough RAM, if you don't have enough resource, you can use the real hardware, right? Real memory, but it will make it slow, right? Because it is far away from the CPU. RAM is closer to CPU. I have a SSD, so 16 GB space from SSD will be used as a RAM here. But this will be slow, of course. And you need to run the make swap file, then swap on swap file. If you run this all, I'm not going to run it again. you will have a swap file, and you can check with the free -hash command or like with the hash top. Here now I have already swap space here a little bit, but it's not 16 GB, so it was there before. So system already is using kind of a swap area. So this is the memory. We will see in the next, this memory will be full while running the model also, the big ones. After this, simply run here max jobs 2. This will use double threads. It will make things really faster, believe me. Python 3 setup file and install. But I think there should be a requirement, so let me check. Maybe I forget the requirements. So you can also install the requirements in the beginning. So simply pip install -r requirements. This will install the necessary packages also. Then max jobs 2 will use 2 threads, Python 3 setup Python file and install. At the end, you will have pytorch, and you can verify the pytorch version using like this command. Yes, it's normal to see this issue because I'm in the pytorch directory now. So let's leave this directory and run again. Don't worry about this, you will see this error during this video, but it's just a warning. So I have this version now. Successfully, I built the pytorch now. This is good. Let's now create a simple script for the chatbot application with the GPT2 module. I'm going to use Tony for the for the editor, but you can use, this is just a simple, it doesn't have enough resource to, you can run the VS Code, but I want to write with the Vim, but for the, the visual perspective, I just thought that Tony is better. So I'm going to create a simple empty file for now, like a simple chatbot Python. I tried before this already, but I'm going to show you now. It's just a simple the script that how we can use the GPT2 model with the pytorch itself. Without the pytorch also you can run this model. It is possible, but you can use the TensorFlow. Without the TensorFlow or the pytorch, you can still run this model, but you need to change the extension of this model. You can use ONNX runtime instead of if you want to run this without pytorch or the TensorFlow. But I just want to show you now. I just want to show you now with the pytorch example. Later we are going to check another llama model, which is far faster. But it's a good idea to understand first what are the steps. What do you need to run these modules on the server, on the Jetson Nano, or in a computer if you use especially the GPU. So now the first just we need to install. We need to include the dependencies first. We are going to use a transformers. These are the modules for the LLM, large language models, and we need to import them the name auto model for causal LM auto tokenizer. I'm going to explain this, what does mean, why we need these things in a simple manner. Import torch. This is the pytorch itself, and we can use to clean up later at the end. We can use the garbage collector GC. So this will load the tokenizer. Tokenizer is needed when you send the text to LLM. There are tokens like numbers. So this will handle this process, the tokenizer process, whatever. And this it is needed to load the models automatically. Auto model for causal LM language models, large model, language model, whatever. Like a GPT2, GPT3 language models. And we imported the pytorch already. We have pytorch. This is good. We need to be sure first that we are running the GPU itself. Otherwise, there is no point. It will take much time to running the model on the hardware. So CUDA, let's check is CUDA available or not first. We can check with the pytorch. Torch CUDA is available. And print. We can check the number of GPUs. GPUs. Torch CUDA device count should be. Then we can check the GPU name just to be sure. GPU name torch CUDA get device name should be 0. We need to check if it's not the GPU is not available, then it's not need to we need to check the problem. What is the problem there? Then we need to load the model name. Let's say for now GPT2. We are going to run the GPT large also later. And we need a tokenizer that I said before. Tokenizer. auto tokenizer from pre-trained model, model name. Then we need to send this model to the GPU. To do that, just simply type here CUDA. That is it for now. So this will convert the model to, like for tokenizing, the tokenizer. Now we are going to use this tokenizer later in the model itself during when we ask questions to the model. We need to check the paddings for that. Some models needs a padding, like if some models in the questions, the length of the questions should be same. Like if there is a padding, if this length is not enough to fill the complete question, then simply there are paddings. Like for example, the question is a hello, but let's say there should be 3 words in the question. Hello will have a token, and the second and third place will be padded, like adding a 0, 0. Like this is the tokenizing. So if tokenizer pet token is none, we need to check just tokenizer add special tokens, and also we need to check the size here. If the padding, like if the new token is added, the model must adjust its embedding size just with the resize token embeddings line tokenizer. Okay, so we have tokens already, right? But we forget to get the model itself. This is not correct, by the way. This should not be here. I made a mistake. So we have a model itself. We have now tokens. So this will convert the human readable text into the tokens, numbers, right? Then we need to pass this, and also we need to model now. We need a model, auto model for causal from pre-trained model name. This model should be in the CUDA to CUDA. Now this is correct. Later we can get the user input. So user prompt should be input. Simply enter prompt. We can write whatever you like. Then we need to tokenize the input now. So inputs. So this will convert text into token. So tokenizer user prompt. This is text itself, the question itself. User prompt return tensors is pytorch that we just build it, and padding, we have padding true, and truncation true. This can be sent to CUDA as well. CUDA. So padding this means here we have padding already. So this means all inputs have same length, and this truncation like a cut, if the text is too long, then this will be the text will be cut off for the model. We have inputs now, and now we can have outputs. Model generate. So as you see that here we have a model, right? Model, but the tokenizer, now we have inputs, tokenized inputs. Now we are going to send this to model, and model will generate the output for us. Model generates and input IDs, attention max, input attention mask. So we will give like a length, max length 200. So this depends also, if you keep it not long, then the question will be cut off, or the answer will be cut off, So number return sequence 1 means it will produce only one answer. So if you make it 2, it will produce 2 different answers. I just need one answer for now, but you can play with it. We can play it later, is okay. So pet token ID is a tokenizer. This is the end of the text, end of the line. So end of sentence token ID to find the end of the sentence. So do sample true. So means this is enabling sampling. When you ask the same question, this will produce different output according to this flag. And we need to define the temperature parameter. I just give here 1.2 now. We will play with it. If you put it more, like a higher value than the 1.2, let's make it 0.1 for example, 0.7. If you give it 1.2, more than 1.2, the output will be not much predictable, not correct, more creative, let's say. But if you give like less than 1.2, like a 0.7, the output will be quite correct, like a more predictable output. And we need to give like a top K is again like a 200, again like the max length. So choosing the next words, like a most, this this is related with the limit, chooses the top 200 most likely next words. And we can, there are a couple of parameters. So like top P, this is 0.9 that I tried before. So this parameter uses nucleus sampling. So meaning it selects words with a combined probability of 90% rather than just most likely. And we can decode the response now. So response, tokenizer, decode, output 0, special tokens true. So this will remove some tokens. You don't need to see them with your, like in the visually, like the end of text tokens or something. And then we can simply print the response now. This will be human readable response for now. And we can simply release the memory. Torch, CUDA, empty cache, and garbage collector collect to help, to clean the memory. Let's see, maybe I have a syntax error somewhere. Okay, Python 3, simple chatbot. Yes, I made a mistake here. This should be dot CUDA device, torque CUDA device. Okay, so I made a mistake, another typo. So now it's working. There were a couple of typos that I fixed already. So CUDA is available, true. Number of GPU is 1, and GPU name is orin. It's okay. And we are going to use the GPU. GPU is available, and it expects a prompt now. So it will not a question. So we are going to give Jack a text, and it will complete the text. So like I am Trump, and I want to invade. Click the enter. Yes, I am Trump, and I want to invade the world, but I'm not sure what to do about it. I'm not sure what to do about the fact that I'm a man who is looking for it will create a text. And if you check it already, like here, this will, this is cut off here because there are 200 words probably already. So if you want if you change here like a 50, for example, max length together. So if you run again, so you don't need to run the script again and again because each time model is loaded. So you don't need to load the model. You can load the model once, and you can ask or give the prompt, you give the questions, you give your text. You can just load the model first, and in the while loop, you can expect more, more than once prompt. But right now, as a prompt, it's also this typo here again. But I just did it for like a simplicity. Like I am Elon Musk, and I will colonize the. So it will create a 50 word now, and it's not cut off. It's like more logical. So I'm Elon Musk, and I will colonize the universe. Okay, it's a great idea, but I am not really interested in the space program. I'm going to be the first person to do it. I'm not interested in NASA. We can now, it is how we can be sure that the GPU is running. This is also another question. So there is a tegra stats command. If you grab this grtd frequency, so now this shows the GPU, the usage. So it's a 2%, 3%. It's not using, it's not. GPU is not available for now. Nobody is using GPU. Let's try now to ask a question and see, how it will go. Like world, I believe world is flat. And so this will generate a response. And while generating a response, you see this is 70%, 3%. I think it created already. It was quite fast. But let's to be sure. Okay, to be sure that let's change this to 100 again. So it will produce longer answer, longer output. Okay, I believe world is flat, and I am. This will create a response, and we can check parallelly. The GPU frequency is as you see here, once is a 66, 95. So GPU is used by our program. I'm going to make it a lot nicer. Okay, so this was GPT-2. This gives kind of a response okay, this completes the text. It's quite like a basic model according to the GPT-2 large is better than this. So there is a GPT-2, GPT-2 medium, and GPT-2 large models. We can try the large one, and we are going to see a problem probably. So by the way, I tried this before, right? So I installed this, I load these models before. That's why it's quite fast for me. But if you do this the first time, you need to wait a little bit, and it will pull these modules from the Hugging Face, not a Hugging. This website, Hugging Face website. Like if you type here GPT-2, so this is the model that I'm using now. You can find related data, explanations, like that, like what we did here, like tokenizers, you know, pre-trained models that I just took the code from here actually. And like that you can find the files here that I just you know, like I couldn't find the model. Where is the model now? So you can find the models from here, from this page, the GPT-2 itself. So this will load the model from here. That's what I'm trying to say. Then we can try GPT-2 large model. So let's try to simply run the program again. I expect the program should fail now because the large GPT-2 large is quite big for this hardware. That means we are going to create the swap area. Yes, let's see. Yeah, skilled. So I see, I couldn't see even the prompt. So this is because of the space, the memory now. So what we are going to do, that I just showed you just a couple of, you know, like a minutes ago, we are going to create the swap area, like a 16 gigabyte, that will help to load the model. So sudo allocate fallocate -l 16 gigabyte swap file, and we can like just give the permissions 600 swap file and make swap file. Yeah, it's okay. I just created before. Swap on swap file. Then that is the thing. Now we need to see when we check with hashtag command. So now we see here 19 something gigabyte swap area. So there was before already some kind of like some space. I added more on it. So let's try to run. What is it? Let's try to run our simple script again. Unless we can check parallelly with the desktop what's happening. See, the RAM is quite filled up now. So it loads the model and the RAM is full now and uses the swap area. Insanely huge GPT-2 large for this model, for this hardware. And now it's ready. Now it's working. Now let's ask the same question that I just, you know, give the same text that I am Trump and I want to invade. Let's see what will give us. This will give more reasonable like output as I expect. So this takes time because it is like bigger than the GPT-2. We can also see with the like a 99%, see that was it created already. So like I'm Trump and I want to invade. Okay, it creates empty. She wrote, I'm a strong woman and I'm proud to be an American. Whatever. Black Lives Matter. Okay, I don't know what does mean. So like let's try again. Yeah, low memory is okay. I am Elon Musk and I want to colonize the, let's see. Parallelly we can check the GPU frequency now, like it should be quite 99%, but it's quite still fast. So I'm Elon Musk and I want to colonize the entire world. If you want to see the full interview, click here. It found a text from the like internet. Like we can ask let's write something more logical again. I would like to cook pasta, but I don't know how to do. I have some ideas, but I don't know how to make it. I hope this helped you guys. Cheers, David. Yeah, it's just weird text. Let's play with the model parameters. So that this is simple, right? As you understand, like there is a model, you load it. It will be loaded from this Hugging Face website and this repository, and there are parameters that you can play with it using the pytorch. So where is the pytorch is important? Here, return tensor for the calculations. We are using pytorch. The pytorch is used, you know, in the background. We didn't use direct, right, for tensors. We can do that, but for the simple example, we don't need now. And we have a, you know, like a model, and this will generate the output. So while generating the output, we have kind of a parameters to play. So like this is 0.7 now. Let's give this 1.7. And this should create now more weird response. But let's try. Let's see. I'm going to write like I'm a Trump and I want to. Then let's see what it will bring us. The model will bring probably more weird response. So this is the idea. There's a black box, the model, and there are parameters that you can play with it. I am Trump and I want to. Takes time. I'm a Trump and I want to on earth. Ground is always beneath us. That has and won and remains sacred to you guys. So as always, use me as much as might. There's something weird. So like according to parameters, you can play with the model. That is the case. But this is like I just wanted to show you like how you can model, how you can use this with the pytorch. There are better for me. I mean, if you ask me, there are better models, and we can use these models without building the PyTorch. That's why I just want to show you. So this is the hard part. You don't need a PyTorch actually. And instead of GPT-2, we can run different models. Like now we are going to test llama, one of the llama models, and this will be like a chatbot. Like we are going to text with it. We are going to chat with it. Let's check this llama model now. So to use the llama, we need to build llama CPP. We already in the beginning install some dependencies, and we need to install the model. For this case, we need the Hugging Face hub I installed before already. So using this Hugging Face tool, we are going to install the llama model, so a directory. Then later we are going to give this path of this directory to the model itself. And simply you can like clone the model I have already again. And you can create a build directory, and run the cmake and enable the CUDA. ggml CUDA flag should be on. Then this will build the llama framework with the CUDA. You don't need a PyTorch. So there is no requirements, right, for this, because it's a CPP project. It's not a Python project. So that's why you don't need to care the requirements for now, like a Python one, like a pip install requirements. And after building, when the build finished, you need to you need to run with the minus make, and you need to run make. Then when it ends, you need to simply there is here like a model directory from here. I already have some models. So as you see that these are there are extensions for it, gguf. So the GPT-2 has different extension than the llama models. So they are different. So you cannot run like what we did before. You can't run the gguf extension. They are different. That was my point actually. So if you install the Hugging Face, the hub tool, using this Hugging Face client command, you can download the Mistral, the model that I'm going to use it now. Mistral, that you can find this also Hugging Face website, the repository, the blog, Mistral 7b instruct v01 gguf, and you need to send this this is local directory now. I'm in the build directory, but if you go the model and run this Hugging client command here, download the model itself as a model name here, then there's no sampling links or something, then you will keep the model in this directory. So let's go back to the build directory. Now you have in the bin file, if you finish the build, there's a client and server binaries that you can use directly these to run the model itself. So let's use that I created before. So using the client commands, this model Mistral that I installed, like with the interactive prompt and GPU layers 999, that means use GPU, and so that means this will use the as much as possible GPU layers, and this will the number of tokens like a 2048. It's a context size of the tokens. Let's run it. This will there are some parameters that you can check according to a architecture llama. The numbers, layers, 32 layer, relates with the AI module. It already gave a question in the beginning. It does this randomly. So now you can ask, this will work quite nice, where is the capital of France? So it's working very nice, why Elon Musk wants to go to Mars or Jupiter, let's say. Jupiter to establish a human settlement on a planet. It gives a logical answers. Just running locally, on the small hardware. It's quite nice that you can play with it at home. You can ask logical math questions, what is the result 2 plus 5 7, or what is the result of times, I don't know what is the result for it, but so this gives logical results. This is good. Why Trump, can I clean here? No. Okay, sorry. You shouldn't click the enter again. Why Trump wants to invade. Okay, it's just Canada. So it's quite also up to date. So these are the a discussion now, topics on the internet. We can ask world is flat or not. Scientists, experts agree that the world is not flat, but rather it is sphere. The idea that the world is flat has been proven to false through the variety of scientific methods and observations, including the curvature of the horizon, the behavior of light and other forms of electromagnetic radiation, and the ability to measure the curvature. Yes, I got nice and logical answers. I like it. I can talk with it. So can you provide me a hello world application, hello world code in Python and C++? Also, you can ask, like a code questions. Just in Python is a print hello world, and in C++. So this is better. This is better than the GPT-2. It's then simple to use. We can check still like a GPU is like a 99%. We can check with hashtop. The RAM is still, there's enough space. Let's ask again something. I forget how to cook rice with chicken. Can you help me? So GPU is running 99%. And yeah, memory is okay. See, the CPU is not, there is still enough space for CPU. This is good. So it gives kind of instructions. Looks good, So like you can ask, I don't know, whatever you want. Like let's try with the language, like how to say, how is it going in Turkish? Nasıl çalışıyoruz? No, it's not correct. Yeah, but it's something, okay. Or like language, maybe Turkish is not a good idea to ask this. Let's ask like in Dutch. How to say? Let's check the memorization. That I'm not going to ask like a previous question, but like how in Dutch? How gaat het? Yeah, it's good. So it's also memorize the previous questions in Chinese, in German. Let's say I don't know how to tell this story. And like in Polish, I have no idea. Okay, let's ask some stupid questions like who wins if Trump fight with Putin in a cage? Highly skilled hand-to-hand combat and have different fighting styles. However, it is worth nothing to cage. Okay, between leaders. Conflict between leaders. It's important for leaders to find peaceful and diplomatic solutions to their differences. You are right. Why there are still wars in the 2025? Well, it's nice. You can talk with it. It's like a free, up-to-date model. So you can test. Also, this is like you can convert the speech to text, and you can send the text to this model. This is also possible, but this is running on locally, right? So like you need a prompt for it. But also there is a way that using this tool, there's a way to run this on the web browser itself also. So like skill this, and let me check the server. Should be server. So now the 000, you can give the host the IP address. Like that means this should be accessible, from the network. And instead of client, you should use a llama server. So this is the same model, and the port number, IP address, GPU layer again, and the token number. So like this one I added before, like generates 70 like a token number. It will generate this short answer. So you can increase this like a 250 or like a -1 unlimited text generation. When you run this, so this will not give you the prompt. Instead of the prompt, you can, I don't remember the IP address. Yeah, this is so if you go to the web browser, so now we have a prompt itself. Let me make it a little bit smaller this. So I did run it before, but let me delete this. And now we can ask like a ChatGPT. Like it's running locally, as you see, it's the local IP address somewhere on my, the switch. So like where is the capital of, what is it? Germany. The capital of Germany is Berlin. So you can also access this from your phone, like, I don't know, from your like Wi-Fi devices or wherever you want. Like who sings like a Stand By Me? Another question, Stand By Me first time. The song Stand By Me was first performed by, yeah, this is the correct answer. It gives like a good answer. Looks good. So this was the other command that you can run. So that you see differences, right? GPT-2, for GPT-2 you need the pytorch, TensorFlow, or if you don't want to use a pytorch or TensorFlow, you need to convert the type that I didn't show you. Maybe we can check later. But Llama, with Llama, it's so simple. You can also create the web browser also, the web browser interaction. The next time we are going to check the DeepSeek. That also we are going to create a kind of a projects with it, like real ones, like a speech to text, real chat box, that kind of fun projects with the AI. But the point is now, this is like a running on a small hardware. It's running quite nice for like a daily usage. These are enough. So I just asked ChatGPT, let me delete this. So it gave me the program that there's a error, like a simple, like it divides the 10 with the 0. So I'm going to ask that, what is the problem here? It's like a simple question. The code here, this one, this tries to delete the divide 0 to 0. So it's a code that we provided a simple program that performs integer division between two variables, x, y, then the program then outputs the result of the console. The problem with this code is that it does not include any error handling for case where y is 0, which would result in undefined behavior. So it's like it's good to like check the problems, ask daily questions. So yeah, like it's working very well. You can play with also like the parameters with it. Also you can check the output, the log, how many like a token for each question, like a 43, 57, looks good. So that was it. And the next tutorial, then we are going to play with the DeepSeek using the Jetson NX Orin again. That I just want to show the differences for you. So you have an idea now how you can use the PyTorch, how you can build a PyTorch if you need, and how you can you can load the model for the GPT2, GPT large, and how you can use a swap area to help the hardware for the memory perspective, and how you can run the llama models, which are quite better now, easily on the Jetson Orin NX using the llama CPP, and you can just build it, you learn how to build the llama CPP, the tool. See you next time.